On November 5, 2025, the Virtual Telescope project unveiled 2 new images of the interstellar object 3I Atlas, revealing details that left the scientific community even more bewildered. The photographs show Atlas as a compact light source, devoid of any visible cometary tail. Even more astonishingly, its appearance has remained virtually unchanged since the Hubble Space Telescope captured images in July 2025. Avi Loeb, an astrophysicist from Harvard, calculated that, considering the object should have lost at least 13% of its total mass, equating to over 5.5 billion tons of material, the absence of a massive bright coma is simply unfathomable. To put this into perspective, the same images also featured Comet Lemon, a typical comet from our solar system. Lemon displays exactly what one would expect: a distinct and bright tail extending away from the sun due to solar radiation pressure, pushing gases and dust into space. Conversely, Atlas remains strangely pristine, lacking the visual evidence typically associated with the substantial material loss necessary to explain its non-gravitational acceleration. According to Loeb, this further supports the idea that Atlas is acting in ways that defy our understanding of natural objects. This leads us to a critical question that scientific inquiry must address seriously. There has been a significant amount of misinformation and alarmism surrounding Atlas and its acceleration. In this video, we will delve into the actual data and determine whether this might indicate something extraordinary occurring within our solar system. On October 29th, as Atlas neared its closest point to the Sun, it began accelerating in ways that gravity alone cannot elucidate. A report presented by NASA's Jet Propulsion Laboratory indicated that Atlas is positioned 4 arc-seconds away from where it should be according to gravitational calculations. Although this might not seem substantial, when tracking an object 203 million kilometers from the Sun, this deviation is enormous. The object is accelerating at roughly 0.02 mm per second squared. To put this in context, over just 1 month, this slight acceleration pushed Atlas approximately 80,000 kilometers off its expected path. The acceleration consists of 2 components. It is pushing away from the Sun at 135 km per day squared, resulting in around 60,000 km each month, while also moving laterally at 60 km per day squared, adding another 27,000 kilometers laterally. Thus, this object is not simply drifting in one direction. It is simultaneously being pushed outward and sideways. Now, before anyone worries, this acceleration does not mean Atlas is heading toward Earth. The deviation is insufficient to alter its trajectory toward any planets in our solar system aside from Jupiter, where it is anticipated to arrive in March 2026. So, what precisely does non-gravitational acceleration entail? Consider it this way. When you toss a ball, gravity pulls it down along a predictable trajectory. However, if that ball suddenly had small rockets firing on it, its path would deviate from the expected. That's what's happening with Atlas. It is not following the trajectory dictated solely by the Sun's gravity. Something else must be propelling it. For a comet, the natural explanation would be outgassing. As ice heats up near the Sun, it vaporizes and emits gases like a rocket engine. This behavior is entirely typical for comets. The difficulty arises when trying to account for the volume of gas that would need to be emitted by Atlas to produce this acceleration. This is where things become particularly intriguing. Avi Loeb conducted calculations based on basic physics principles. By knowing the acceleration and the object's mass, one can ascertain how much gas would need to be ejected to generate that force. Atlas has a mass of at least 33 billion tons, which is immensely larger in comparison to the first 2 interstellar objects we discovered. It is between 1,000 and 1 million times more massive than Oumuamua or Borisov, with its core estimated to be around 3.5 miles or nearly 6 kilometers in diameter. Given this mass and the observed acceleration, calculations indicate something astonishing. To produce push-through natural outgassing, Atlas would need to expel at least 16% of its total mass during the month surrounding its closest approach to the Sun, amounting to at least 5.5 billion tons of gas. Such a volume of gas would create an enormous and remarkably radiant cloud around the object, impossible to miss with our telescopes. Between late November 2025 and late January, numerous ground-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, will be monitoring Atlas. On December 19th, it will be at its closest point to Earth, roughly 167 million miles away. If that significant gas cloud exists, we will observe it. But what if it doesn't? That's where the scientific discussion becomes genuinely captivating. Should we fail to detect the gas cloud that would correlate with the gas needed to account for the observed acceleration, we would have to seriously entertain the notion that the acceleration originates from something else, something man-made. Remember, we've witnessed this exact scenario previously with Oumuamua. The first interstellar object also exhibited non-gravitational acceleration, but revealed no gas or dust escaping it. Even the highly sensitive Spitzer Space Telescope could not detect any outgassing. Consequently, scientists dubbed it a dark comet, a term that contradicts itself, as the defining trait of a comet is its trail of gas and dust, yet Atlas is displaying even stranger behavior than Oumuamua, demonstrating two additional peculiar characteristics that render natural explanations even more challenging to accept. First is the brightness aspect. As Atlas drew closer to the Sun, its brightness intensified, adhering to a power law with an exponent of 7.5. For those unfamiliar with mathematics, this means that ordinary comets brighten as they approach the Sun, following a power of 2 to 3. However, Atlas is shining much more rapidly than any typical comet, increasing at more than double the rate we would presume. This phenomenon is entirely unprecedented. Secondly, and this marks the ninth anomaly, Atlas is bluish in appearance. It seems bluer than the Sun itself at its closest approach, which is extraordinarily unusual because dust tends to make objects appear redder, not bluer. The surface of Atlas should be about 20 times cooler than that of the Sun, and cold surfaces typically emit a reddish glow, not blue. So why is it appearing blue? Natural explanations might involve ionized gases, such as carbon dioxide emitting light directly, a possibility to consider. Now, it's crucial to grasp what is truly being debated here. Scientists aren't asserting that Atlas is definitively alien technology. Rather, the discussion revolves around scientific methodology. In cases where data contradicts existing theories, it is unacceptable to merely dismiss the data. It must be taken seriously, and all potential explanations, even those that may be uncomfortable, should be explored. Some scientists suggested the data must be erroneous simply because they could not provide an explanation. Dr. Avi Loeb countered that this represents poor science. You cannot assume the data is wrong merely because you lack a corresponding theory. Atlas is a unique object within our solar system, not just showcasing the facts, but also their implications, each of which challenges conventional understanding, below or from either side. However, Atlas approached almost perfectly aligned with the planet's orbital plane, making the chance of this occurrence due to chance a mere 0.2%, akin to hitting a tiny target in the darkness. The second anomaly pertains to the jet that contradicts physical laws. During July and August 2025, Atlas exhibited behavior not previously observed in nature, producing a jet of material directed straight toward our star. All known comets, by contrast, create tails that point away from the Sun, just like hair blowing in the wind as you run. This is governed by fundamental physical laws. Solar radiation pressure pushes material outward. Atlas seemingly defied this basic principle, resembling someone running while their hair is blowing forward against the wind. The third anomaly relates to its size and speed. Atlas is 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov. Yet it is still moving quicker than comparable objects. It's comparable to discovering a massive truck overtaking race cars on a highway. Larger objects in interstellar space typically travel more slowly due to the gravitational forces involved in expelling them from their originating systems. Atlas contradicts this rule with extremely low probability. The fourth anomaly concerns its perfect timing. Atlas appeared with impeccable timing to pass close to Mars, Venus, and Jupiter, but remained undetectable from Earth during its most critical moment, perihelion. It's as if a tourist managed to visit 3 important cities without ever triggering security cameras at the main airport. The temporal accuracy of this sequence is exceedingly rare, exceeding even a lottery win. The 5th anomaly focuses on its composition. Spectral analysis revealed that Atlas possesses substantially more nickel than iron, a ratio that aligns with metallic alloys produced industrially on Earth. Natural comets should exhibit a random assortment of metals akin to a cosmic mixture soup. However, Atlas seems to follow a specific formulation, suggesting deliberate selection of its components. The likelihood of this particular composition occurring by natural means is very slim. The 6th anomaly is that it is drier than a desert. Known as dirty snowballs, comets are typically composed of 80–90% water ice. In contrast, Atlas contains only 4% water, making it drier than many of Earth's deserts. It's like discovering an iceberg predominantly made of rock, which challenges the fundamental definition of what a comet is, hinting that it may not be a naturally occurring comet after all. The 7th anomaly involves its unusual light polarization. Atlas exhibited a polarization pattern of light never observed in any known natural object. Polarization acts like a light fingerprint. Each surface type generates a distinctive pattern. It's almost as if Atlas possesses a fingerprint that does not match anything in the natural world, including all previously studied comets, even Borisov. The 8th anomaly points to its connection with the 1977 mystery. Atlas approached from the same direction as the famous WOW signal of 1977, the most mysterious radio signal ever detected, often considered compelling evidence of extraterrestrial communication. The directional precision is astonishing, akin to 2 events separated by nearly 50 years pointing to the same cosmic address. The odds of this coincidence occurring are quite low. Lastly, the 9th anomaly confirms that it is hotter than our Sun. Atlas now appears bluer than our Sun, implying it has an internal energy source that is hotter than the Sun's temperature of 5,800 degrees Kelvin. It is comparable to finding a candle that shines brighter than a bonfire. This indicates a level of technology capable of generating temperatures that surpass those of our star, pushing beyond our current technological understanding. The physics are straightforward. Considerable acceleration demands significant mass loss. If we do not observe the gas cloud that should accompany such loss, we are left with only one viable explanation that aligns with the data. As we near December 19th, the date when Atlas reaches its closest point to Earth, hundreds of telescopes will be on the lookout for 5.5 billion tons of lost gas. If that gas fails to materialize, we will understand that we are not observing a comet. Instead, we may be witnessing something far more extraordinary. A piece of technology from another world, illustrating propulsion capabilities that challenge our grasp of physics itself. The countdown to what could be humanity's most significant discovery in history has commenced. In just a few weeks, we will find out whether we are indeed alone in the universe, or if we are witnessing our first confirmed visitor from the stars.